In this video, we're going to identify the domain and range of various functions. So before we can actually find domain and range, we need to define what they are so we know exactly what we are looking for. The domain on a graph is the set of all possible input values of a function. So any values that can be put into a function. Typically what we're looking for are all possible x values that can be put into that function. Remember, x is typically input, so when we're finding the domain of a function, we're finding all of the possible input or x values. The range, on the other hand, is the set of all possible output values of a function. So typically what we're trying to find are all of the y values, all of those output values that come out of that function. So when we're finding domain and range, we're finding all of the possible x values or input values and all of the possible output values or y values. So let's start by identifying the domain and range of some functions that we've already seen. So here we can see we have two different representations of a function, and what we're going to do for each is we're going to identify the domain, which remember are our inputs. So I have the domain, which are the inputs, and the range, which represents the outputs. And what I'm going to do for each is I'm going to identify the possible inputs or the x values and the possible outputs or the y values. So to start, I'm going to put x equals and y equals to remind myself that I'm finding x and y values for my inputs and my outputs. Then I start with each point. So this point right here is the point x is -3, y is -2. So my input for that particular point is x is -3, and my range, which is my output, is y is -2. Then if I go to my next point, here I have x is -1, y is 0. So my input is -1, my output is 0. I go to the next point. This is x is 1, y is 2. So my input is 1, my output is 2. And then here I have the point x is 3, y is 4. So my input is 3 and my output is 4. So I simply list all of my input values for domain, or all of my x values, and all of my output values for my range, which are my y values. Then if I look down here at this second example, what I see is a mapping diagram, and I know that mapping diagrams are rearranged with inputs in one oval and outputs in another. So here I see all of my inputs grouped together. So really what this is saying is, okay, my domain is all of the x values inside of this inputs bubble. So that's -3, -1, 1, and 2. My range are all of my output values, or my y values, and they're in this outputs bubble over here, which are the values of -2, -1, and 0. So we're going to go through the same process here. We're just going to identify our domain and our range for each, noticing that my domain are all of the x values and my range are all of the y values that we have. So my domain, if I look at each point individually, this is the point x is -2, y is 4. So if I go over to my domain, my input is -2, my output is 4. The next one is x is -1, y is 2. So my input is -1, my output is 2. Here I have the point 0, 0. So I have an input of 0 and an output of 0. Here I then have the point 1, 2. So I have an input of 1, and then I notice I have an output of 2, but I already listed that here, so I don't need to list it again. So I'm not going to repeat it. I just know that I've already included that in my list of outputs. Then here I have the point x is 2, y is 4. So I have an input of 2 and an output of 4, which I can already see that I've listed, so I'm not going to repeat it again. Okay, the next one I see is I see a table, and luckily it's split up into x's and y's already, so I have my inputs and my outputs. And what I'm going to do is list my domain and my range. Remember, my domain are all of my x values here. So I see x could be equal to -3, -1, 0, and 1. And my range are all of my y values. So remember, this is x and that's y. My y values are 3, 1, 0, and notice that the ones repeat, so I only need to list them once. So I've listed all of my inputs and my outputs for each representation. So now we're going to look at graphs that are a little bit more complicated. So looking at number 5, what you're going to notice is that we have a slightly more complex graph. We don't just have points, we have this continuous piece here where we start at the first endpoint on the left, and then we move through and we go to this endpoint here. So our domain and our range are going to be a little bit more difficult to determine. So here we have domain, we have range, and remembering domain are my x values. So I'm going to focus down here on this x-axis and try and figure out which x values I need to make this graph. So because this is a continuous line, it's really implying that there are points all along this line. So that's what that's implying. There are basically an infinite number of points between those two endpoints. So what I need to focus on here is figuring out what possible values for x could I have. And what I notice if I look here at this particular line is I notice that my x values kind of start with this endpoint here. So they start right here at -2. My lowest x value that I need to make that graph is -2. I could actually cover up this entire side of the graph because I don't need those x values. So my lowest x value is -2. And then I go through and here x is -1 up to 0, 1, 2. And when I get up to here, the highest x value I need is right here at 3. So what happens is I really need all of these x values that are between -2 and 3. I need this part of the x-axis. And hopefully looking at that with the 2 dots and the line in between, you're realizing that that's an and inequality. That's what our inequalities looked like when we had to graph ands. So what's really happening here is x is being sandwiched in the middle of two numbers. X needs to be on the bigger side of -2, and it needs to be on the smaller side of 3. So sometimes we're actually going to write our domain and range as a set of inequalities. And you'll notice here, this implies x needs to be on the bigger side of -2 and the smaller side of 3, which we can see is true if we want to make the points on our graph. Every single point on that line that we see has an x value that's -2 up to 3. It's in that range. Now if we look at the range itself, remember range are the y values, so we're going to focus on the y-axis right there. We need to look for the smallest possible y value that we use. So if we look down here at this endpoint, the smallest y value that we use is -1. The lowest that it goes. We could cross off this part of the graph. We don't need any of those y values below because the graph isn't there. So what we're going to do from here is then look for the highest y value, which if we look, is right here at 2. So essentially what's happening is I have a high y value of 2, a low high value of -1, and I need all of these y values that are in between. So again, we have a sandwich of sorts. We have y in the middle, and y needs to be on the smaller side of 2, but the bigger side of -1. So again, here we have an inequality region. Because this is a continuous graph, and it could have any y value points on any of these points here, we need to have it represented in inequality. Y could range from -1 all the way up to 2. So now if we look down at number 6, we have a different type of graph. So again, we're going to look at our domain, and then we're going to look at our range. So domain, remember, are the x values here, so we're going to focus on the x-axis and the x values that we need to make this graph. What I notice on this graph is that the lowest point on our x-axis that we go to is right here when x is 1, and the highest x value I go to is here at 5. So x gets sandwiched here between 1 and 5. So I'm going to represent that in my inequality. X is going to be on the smaller side of 5 to be in this region, and on the bigger side of 1. Then if I switch that around and I look at the y values needed to make points on that graph, or my output values, I notice that if I'm focusing on these values here, the lowest y value that I use is right here at 0. The highest y value I use is right here at 4. So essentially, I need all of the y values that are between 0 and 4. I need this region right here. These y values help me to make all of the points on this graph. So if I represent this in an inequality, I notice y gets trapped between 0 and 4, and y needs to be on the smaller side of 4, but the bigger side of 0. So these are a little more complicated. They do require more thinking with these different inequalities that you see with the sandwiches, but you just have to think through in order to make every point on that graph that I see, which x and y values do I use? Sometimes you can list them as points. Other times, in order to include every single possible value for y and x, you need to use those inequalities that we've talked about previously. Okay, so here is some slightly more complicated examples. These are not actually functions, these are relations because we have some crossing over of inputs having more than one output. But we're going to still find the domain and the range of each. So remember, domain are all of the possible x values that we could use to make points on our graph. So if we focus here on this x axis here, what I notice are that my x values don't use that entire graph. My x values essentially on the low side start at about -3. This is the lowest x value that I need because again I could cross off this part of the graph. I don't need any of those x values there. So I need x values starting at -3, and then I need these x values to make this part of the graph here, this part of the graph here. I still need these to continue making this part and this part, but what I notice is that my highest point is right up here. So I don't actually need any x values on this side either. Again, I could cross off this part of the coordinate plane. I don't need those particular x values to make points on that graph. So here, essentially what I'm focusing on the x values that are between -3 and 3. On the x-axis, I need these particular values to make points on my graph. So my x values get sandwiched again. I can see that with the two endpoints. So x will be on the smaller side of +3 and the bigger side of -3. Now if I switch gears here and I look at the y values, what I notice with the y values is that I am going to focus on the y-axis. And again, the y values that I need, I don't need any of these. They don't make points on my graph, but they start around -4. And then I'm using all of those up through to +3, where then I don't need any of these y values up here. So I'm essentially focusing on the y values between -4 down here and +3 up here. These are the y values that I need to make different points on this side of the graph or this side of the graph. So my y values are less than or equal to 3 or greater than or equal to -4. Then if I look down here, hopefully this is getting a little bit easier for you. Again, for the x-axis, I'm focusing on the x values that I need to make points on this particular circle. In order to make points on this particular circle, I need the x values starting at about -2 and going all the way to about 2. Essentially, I don't need any of these x values over here beyond 2 or any of these beyond -2. The x values I need are sandwiched between the two. Between -2, that's where the points start, and +2, where the points end. So my domain are all of the x values that are on the smaller side of 2, but the bigger side of -2. Then from here, if we flip this around, again, we're going to look at the y values that we need to make points on our graph. So here, we're going to focus on the y-axis. And again, I need to figure out which y values do I need. Well, I don't need any of the y values down here to make points on that circle. All of my y values start at about 1. They go up to about 5, and then I don't need any above 5 either. So my y values are focused here between 1 and 5. So my range are going to include all of the y values that are on the smaller side of 5 and the bigger side of 1. Last two examples of domain and range, and I just want to show you these because they're a little bit different because these contain arrows on them. So here you can see that we have a line with arrows that continue, and what these arrows are implying are that this graph goes forever this way and forever this way. this graph continues on forever in the direction of those arrows. So if we're going to sit down and think about, okay, what are the possible x values that we need to make points on this graph? Well, essentially what's happening is this graph is going forever to the right and forever to the left because it's angled and it's going up and down, right and left forever. So if you have something like this where you have x values and you're going forever in both directions, what this is telling you is that you're using every x value that you could possibly use on this graph that continues forever in both directions. So what you can write instead is that your domain is all real numbers. You are using every possible value for x that you might possibly need. Everyone, from negative infinity up to infinity, you're going to use everyone to make points on that graph because it continues forever in both directions. Now here again, because this line is angled, I notice that I'm going forever up and forever down. So again, I have this situation where my y values are going forever up and forever down, which again is an instance where it's telling me that I need all real numbers for y to make points on this graph. And the final example down here at the bottom, I'm going to erase a little bit of this to get out of the way. This one, what I notice with x is that this graph is continuing forever this way and forever this way. So if I'm focusing in on x, I notice I'm going forever to the right and forever to the left. That's what those arrows are implying. So my domain for this particular graph is simply going to be all real numbers because I'm going forever to the right and forever to the left. Then from here, if I look at my range are all of the y values that I need, and what I notice down here is I have a little point down here that seems to be important. That's where it changes directions, and that acts as a low point for y. And then what I notice is this graph is going forever up. So if I'm focusing here on the y-axis, I'm starting down here at 5, and I'm using all of the y values that are going up. So what that's telling me is that my range, all of the y values that I need to make points on my graph, start at 5 and then work their way up. So my range would be y is greater than or equal to 5.